Learning target 2.5, I can determine the number of valence electrons in an element using the periodic table. All right, easy stuff here. Reason why? We're talking about something called valence electrons, and we're talking about the periodic table. Okay, so valence electrons, as a reminder, are just the number of electrons in the outermost level, right? So number of electrons in the outermost shell or level, or however you want to think about it. Okay, so you use the group number on the periodic table to figure out how many valence electrons are in that element. Okay, so here's my handy dandy periodic table. Okay, here's group 1, group 2, 3-ish, 3 again, 4, 5, 6, 7, 8, 6, 5, 4. Okay, so remember groups go down, so I'm just going to really quickly jot where each group sort of starts and ends. Okay, so here are all my groups. Well, if I'm talking about an element that's in group 1, like K, then I know that K will have 1 valence electron. Okay, group 2, if I talk about something in group 2 like calcium, that's going to have 2 electrons. Group 3 is a little bit weird because these are the transition metals and they just like to make things crazy. But don't worry, you're not going to have to worry about that on your CSTs. The group 3s that are here, so starting with boron, yes, those are going to have 3, and then 4, 5, 6, 7, and 8. Okay. Now there's one exception, right? And that one exception is helium. Helium is not going to have 8 electrons. Why? Because it doesn't have 8 protons. It has 2 protons. The maximum it can hold is going to be 2. So helium has 2 electrons in its valence shell. That's the exception. Okay. So let's go ahead and try an example question. Elements found in group 2 of the periodic table have blank valence electrons and blank spaces available for bonding. I already know that it's group 2. If it's group 2 and we're talking about valence electrons, it's going to have 2, right? Number of valence electrons is found by looking at the group number. So I can cross out this and this because we know it has to have 2 valence electrons. Okay, now the second question we didn't really talk about, but it's blank spaces available for bonding. So we're going to get into bonding really soon, but if you imagine, how many electrons does the outermost shell want to hold? Maximum. It wants to hold a maximum of 8, right? That's when it's happy. That's called your octet rule. Everyone wants to get 8. So which one of these would be the correct answer? 2 and 6, right? So it would have 2 valence electrons, and it wants to gain 6 more so that it will fulfill the octet rule. Okay, so summarize. Elements found in group 2 of the periodic table have 2 valence electrons and 6 spaces available for bonding.